right, here is the review for circles that was actually given to you as a take-home quiz on Wednesday, and you should have it back if you brought it back to school today. First thing you have to recognize on these three problems is they're all about the fact that a tangent line or segment is always perpendicular to the radius. So in numbers 1 and 2, it's asking if it's a tangent. You're not being asked to find a missing side. You're being asked, is it a tangent? So you're seeing, is this perpendicular, which means, is it a right angle? Which means the Pythagorean theorem should work if it is. So that's what you're doing. You're checking Pythagorean theorem, basically. On number 1, notice that that 8 is only the radius. So this is 8 also. So this whole side of the triangle is actually 16. So what I'm checking is whether 11 squared plus 16 squared equals 20 squared. So in my calculator, I would go ahead and do 11 squared plus 16 squared, and that gives me 377. And over here, do 20 squared, that should give me 400. Those don't equal, so I put is not equal to, and so no, it's not a tangent. Sorry, that was sort of slanted there. Number 2, same idea. 9 squared plus 12 squared should equal the hypotenuse squared if this is a tangent. Now let me just point out the hypotenuse. 7 is not the entire hypotenuse. 7 is only the part outside the circle, because they know that you already know this part is 9. How do you know? Because it's a radius, just like this one. So 9 plus 7, this whole thing is 16. That's a familiar number here. So the question is whether 9 squared plus 12 squared equals 16 squared. 9 squared plus 12 squared gives me 225. 16 squared gives me 256. So this is another no. So this is not a tangent. On number 3, they say, go ahead and assume that lines that appear to be tangent are tangent. So this time, we're not checking to see if it's 90. We're saying, okay, yeah, this is 90. How can I find that side? Pythagorean theorem again. So let's call that side x. And we have x squared plus 10.5 squared equals 14.5 squared. So I would go ahead and do this in my calculator. You're going to end up subtracting 10.5 squared from both sides. So I would go ahead and do that in my calculator. Do 14.5 squared minus 10.5 squared. That gives me 100. So that made that go away. X squared has to be 100. That's x squared. You always end up having to unsquare at the end of the Pythagorean theorem, which means square root. So x is 10. Number 4, a lot of people did the parts of this correctly, but then didn't find the perimeter. You have to add them all up. So remember, this is the ice cream cone theorem. If this side is 11, this side's 11. They're the two sides of the cone that don't want to let my ice cream drop. Okay, if this is 8.3, then this is 8.3. To find this part right here, I can subtract 8.3 from 14.5 in my calculator and get 6.2. So if this is 6.2, this is 6.2. And now I have all the sides and I can add them up. And 8.3 plus 8.3 plus 6.2 plus 6.2 plus 11 gives me 51. And that's my answer. Now down here, numbers 5 and 6, these are central angles. It even tells me that. Okay, so if that arc is 70, this angle is 70. If this angle is 47, this arc is 47. It asks me about angle EBF. That's EBF. So I'm going to use the fact that this is a straight line, this is a diameter, so everything on this side of the triangle, on this side of the circle has to add up to 180. So 70 plus 47 plus this number here have to add up to 180. So I'm going to add 70 plus 47, and that gives me 117, and then I'm going to subtract that from 180. and that gives me 63, and that's my answer right here, 63 degrees. Number 6, also about central angles. Central angles, we have, this is 60, this is 70. They want me to find USW. A lot of people successfully found this angle right here. And that angle right there, this all has to add up to 180. So I go 60 plus 70, and that gives me 130. Subtract it from 180, and I get 50. The problem is some of you didn't read what it was looking for. USW, USW. That's this whole angle. So 50 plus 70, which is 120. And that's your answer. All right, on the back of the page. First, we have a line that goes through the center of the circle, and it intersects a chord at a right angle. That means it always cuts it into 2 equal parts. So this is also 9. Same thing happens over here. So if this part down here is 10.1, this part right here is also 10.1. And now I have a right triangle with 2 legs, 5.4 and 10.1. So 5.4 squared plus 10.1 squared should give me x squared. So 5.4 squared plus 10.1 squared, it gives me 131.17. I saw a few people who put that as their answer. Remember that at the end of the Pythagorean theorem, you have to take the square root. So x is 11.45. All right, numbers 9 and 10 and let's see, beyond. A lot of these are inscribed angles or angles that have their vertex on the circle. Remember, if an angle has its vertex on the circle, then the angle is half the intercepted arc. Okay? Use the information you have, even if it doesn't seem to be what you need. Like, that doesn't talk about this angle this arc over here, but it's going to help us to find that arc. 74 is half of the blue arc, so 74 times 2, that's 148. And now what I have is I have 134, I have 148, I have everything on the circle except that question mark. So I'm going to add up 148 and 134. That gives me 282. And I'm going to subtract 282 from 360. When I do that, that gives me 78. And that's my answer for number 9. Number 10, it really can help to trace that angle. See that 37? Don't start out looking here. Look at what you have and see what you can do with it. This angle is what I have. If I have that angle, then I can find this arc because the angle has to be half the arc. So 37 times 2, that's 74. Okay, now notice that QS is a diameter. You're almost always going to use diameters to cut the circle into 2 pieces so that we have less to work with. Now all I have to worry about is this 180. Well, if I have 180 over here and I know 74 is there, 180 minus 74 will give me the rest. And that's 106. And that's what this arc is right there. Number 11. There are several different ways you can look at this. I would start out probably, let's see, I'm going to trace this angle. This is the angle I want. And look at what arc it cuts off from the rest of the circle. It's this arc right here. Well, notice that that blue part is everything that I don't know yet. I already know the rest of the circle. I know that all of this is 60 and 126. 60 and 126 together is 186. So if I take 360 minus 186, I can find out how much this is of the circle. 360 minus 186, is 174. So this is all 174, this blue arc. Now that is half of 174. So that'll give me 7 degrees, and that's my answer. Number 12. Okay, again, trace the angle. I better see a lot of people doing that on their test, let me tell you. Okay, and here's the arc it goes with. So I need to find that arc. Well, look again, I have all the parts of the circle except for that arc. So I'm going to say 150 plus 120, that's 270. That's how much I need to subtract from 360, and that gives me 90. So this is 90, which means this is 45, half of 90. Number 13 is a little challenging. What you have to realize here is that 104 is one of the two arcs you need. Remember, outside, inside, on. When it's outside, the angle is half the difference between the two arcs. So here it's outside. I need this arc, but I need the rest of it too. Well, the rest of it, the long way around from Q to S, would be 360 minus 104. So I'm going to come over here and do that. 360 minus 104, that's 256. So this part out here is 256. Now I can plug in to the equation or the formula. Angle equals 1/2 256 minus 104. So I'm going to do 256 minus 104 and divide that by 2, and I get 76 degrees. That's my angle. Number 14 is just crazy easy. It's an inscribed angle because its vertex is on the circle, so it's half of that arc. So half of 170 is 85. That's all. Same thing with number 15. This is on the circle, so the angle is just half the arc. If that arc is 80, then the angle is just 40. Number 16 is almost as easy. Here's the angle. It's on the circle, so it's going to be half the arc, but the arc is this arc right here. We have this arc over here. Subtract 360 minus 220, and we now have the information we need. This is 140. Half of that would be 70. And that is it.